Hey everyone, welcome to this lecture. Okay, yeah. So in this particular lecture, we would understand some of the example of the Bayes theorem, which will allow us to understand in a real way, in an example way, that how do we use it, the Bayes theorem, and some examples. Okay, so let's get started with the first, our first example, which is nothing but the cards. Okay, the classic probabilities. Uh, for the any probability, we take the cards for the better understanding. So let's get started. Okay, so first of all, let's see what is our Bayes theorem says. Okay, what our Bayes theorem says, it says that what is the probability of an event given that another event has occurred already. Okay, occurred already. And what is the uh, formula for it? It's nothing but probability of event first. Okay, the first event given that A has already occurred, into the probability of event A divided by probability of event B. Okay, got this? I know you know it very well, and you don't have to like make it very complicated, oversimplify things, then overcomplicating. Okay, so now let's get into the first example. What it is saying. So the first example, what is saying about the cards. So as we know that the playing cards, it contain 52 cards. Okay, 52 cards. And for the quick revision, let me tell you, you all would know that, but in the 52 cards we have four groups. Okay, diamond, club, spade, heart. Sorry, heart. Okay, and each has 13 cards. Each has 13 cards. Okay, each has 13 cards. And what this example is saying us, that we have set two events. Okay, we have set two events. Event A says the card that should be drawn, it must be a queen. Okay, the card drawn is a queen. Event A says the card, whatever card we draw, it must be a queen card. Okay, and then we have event B. What this says, that the card, whatever card it is drawn, it should be a face card. Okay, so we have two events. First event, first, not the first event, we cannot say the first or last, but we can say that the events we have. So event A says that the card that we are drawing, it should be queen card. Okay, and the second one saying, the event B, that if the card is drawn, it should be a face card. Okay, now we have to find the probability, that what is the probability of a queen card. Okay, what is the probability of getting a queen card given that the face card has already occurred. Okay, the face card has been drawn. Okay, so now we have to find some quick probabilities for finding the probability, because in these the Bayes theorem, we cannot find probability just by using one probability. Okay, you could see that here we have three probabilities, this, and we will understand it is what all these says. Okay, yeah. So this is our first probability, which says that what is the probability of drawing a queen card. Sorry for my pronunciation, but queen card. Okay, so as the classical probability, yeah, we know that. How do we find the probability of getting a queen card equal to total number of outcome. Okay, the total number of favorable outcome given by the total number of outcomes. So we have four queen cards. Okay, we have four queen cards in the whole 52 number of cards. Okay, in the 52 number of cards, we have four queen cards. Okay, and after simplifying it, we get 1 by 13. Okay, so the probability of getting a queen card in the whole, understand, in the 52 cards, the probability of getting of the queen card is 1 by 13. Okay, right, clear? Now the second probability, that what is the probability of drawing a face card. What is the probability of drawing a face card in the whole 52 cards? Okay, remember this, in the whole 52 cards, we are just drawing the probability, we are just finding the probability, we are not actually applying it, we are just finding the probability for finding into the Bayes theorem. Okay, now the probability, this B event B says the probability of B is the probability of drawing a face card. Okay, so what is the probability of getting a face card? So what is a face card is actually in a face card we have actually three cards. Okay, king, queen and jack. Okay, and as we know that we have four groups, we could say that four groups, then it would have three, which is nothing but if we sum it all up, then we would get 12. What it is 12. Okay, and this is what we have. It is our the favorable outcome that in the whole 52, okay, understand, in the whole 52 card number of cards, we have only 12 card which are face card. Okay, so what is the probability of getting a face card? Is nothing but 12 by 52, which is 3 by 13. Okay, after simplifying it, is nothing but 3 by 13. Now, this part is something that we need to understand. If you got this part, then the whole probability of finding the base theorem would be much easier. Okay, it would be much easier. So let's understand this. What this probability says, what is the probability of getting a face card if it is a queen card? Okay, what is the probability of getting a face card given that the queen card has already occurred? Okay, probability of drawing a face card given that the card is a queen. If the card is a queen, then it is definitely that it is a face card. Now, what we have uh, talked earlier, that face card. Okay, in the face card we have queen. Okay, and if it is a queen card, then it would be definitely a face card. Okay, if it is a queen card, then it would be definitely a face card. Okay, and there is nothing to say about that. If it is a queen card, then it won't be a face card. It should be. So the probability, okay, what this says, the probability of getting a face card given that it is a queen card. If it is a queen, it should be face card. So the probability, sorry for my pronunciation. So the probability of getting a face card given that it is a queen card, it is one. It is one, because we cannot, because we don't have any other uh, you know other thing to guess here or like talk about. Because if it is a queen, then it should be a face card. If it is a face card, then it could be three more cards. Okay, okay, but we're talking about what is the probability of getting a face card given that it is a queen card. Then the probability of it will be one. Now we have to just apply in the base theorem. What is it? The probability of getting a queen card given that it is a face card. Okay, so we just have to put all the probabilities that is being used in the base theorem. What is the first probability here is, what is the probability of getting a face card given that it is a queen card? It is nothing but one. See, it is nothing but one. Here we have found that earlier, that is nothing but one. We will put one here, which is one here. Okay, into what is the probability of getting, what is the probability of getting a queen card? Okay, what is the probability of getting a queen card? It's nothing but 1 by 13. We have found it earlier. Okay, where? Yeah, it is nothing but 1 by 13. And now, what is the probability of getting a face card? It is nothing by 3 by 13. Okay, we have talked it earlier. See, it is nothing but 3 by 13. We have just put it here. We did nothing. We just put it in this formula and we simplified it, and then we got our answer, which is nothing but 1 by 3. Okay, and that's how we find our probability in the base theorem. Okay, and this is how we use base theorem. Okay, now we have another probability also where we have some conditions also. This is the basic, the classical one, the classical example for explaining the probability. Now we have another one, the rain. Okay, this is the interesting one. Okay, let's see. So now we have defined the problem. That what is the problem here actually? What do we have to find? Okay, so the in the second example we're talking about rain. Okay, so now we have this defined our problem, which is in which we have two events. Event A says that the event that it is actually raining. So what it is saying, that there is an event in which it is actually raining outside. Okay, in your location, think that it is actually raining, and it comes under the event A. Okay, event A says that it is actually raining outside, not inside. How it could be rain inside? Okay, now we have second event which says that the event that the weather forecast predicts it rains. Okay, so now we always, if we see any condition like cloudy or anything in the sky, then we check our phone in the weather for in the weather app and we see that it rains or not. So who predicts that it rains or not? The weather forecast team. So what the event B says that the event, okay, it is the event in which the weather forecast team predicts it will rain. Okay, so we have two events. The first event says that what is the event says that what is the probability, not the probability that it is raining, and the event B says that the weather forecasting predicts it is raining. Okay, so we have two events. Now we have to find that which is actually true. So now we will find the first probabilities. Now what is, we have the probability A. What is A? What is the probability that it is raining? Okay, what is the probability that it is raining according to our previous data? Okay, so the prior probability that it is raining, and the data shows that it rains 20% in your location. Suppose that there is a rain and the chance of rain is 20% according to our previous data, that if the cloud is in that, if it is that much cloudy, then it will rain 20%. Okay, it does not rain but sometime it rains. Okay, it's 20%, it is not enough but it is 20%. Now we have another probability in which we are saying that what is the probability that it is not raining? What is the probability that it is not raining? It is nothing but the a prime. Okay, probability a prime. A prime is nothing, just to show a symbol. So it is nothing but 1 by probability of it is raining. So 1 minus 0.20 was nothing but 0.80. Okay, this is our the probability that it is not raining. We have found two probabilities. Now the third probability, what is saying that probability that the weather forecasting predicts it rains given that it is actually raining. Okay, now understand the statement here. Probability that the forecast team predicts rain given that it is actually raining. Have we got this? What we are seeing that the prediction of weather forecasting can be wrong also. Okay, it can be wrong also. They would have predicted that it will rain, but it is not raining. They would have predicted it will not rain, but it is raining. They would have predicted that it will rain and it is raining. Okay, got it. So yeah, so the what is the probability that it is raining? Okay, it is actually raining. So what is the probability that the weather forecasting predicted it will rain? It is actually raining. Given that it is actually raining and it is predicted by the forecast team that it will rain, so they almost 90% of the time they predict correctly that it will rain. Okay, 90% of the time they predict that it will rain. So the probability of saying that it will uh, the weather forecast team predicts that it will rain and it is actually raining, it is 0.90. What is 90%? And in the term of probability, it is 0.09. Okay, 0.90. Okay, sorry, 0.90. Now we have another probability which says the probability that the forecast predicts it predicts rain given that it is not raining. Okay, we have two more conditions. Okay, in which the weather forecasting predicts it will rain, but it is not actually raining. We could have also that condition. So it is nothing but 1 minus p of a equal to 0.10. Okay, it is that simple to find that it is not and it is. Okay, so it is that. And now we have four probabilities that it actually rains, it does not rain, it does not rains. And what is the probability of weather forecasting predicts? Weather forecast predict it will rain and it actually rains. Weather forecast predict it will rain but it does not rain. Okay, now we find the probability B. Okay, and this is the evidence, and this is the evidence we call it in the term of Bayes theorem. What we call it? Evidence. Okay, evidence is what is the evidence that it actually exists. So in this, we would we would collect all the probabilities. Okay, we would collect all the probability and we would have a sample space for that. Okay, whether it is or whether it is not, we will have all our prediction or probability into it. Okay, so the probability that the weather forecast predicts rain, whether it is actually it is actually raining or not. Okay, so we would have all the probabilities in which it is raining or not raining, whether it is raining or not raining, and uh, we will first multiply it and then we'll add up. Okay, and this is how we do it, and this is how we do it. Okay, now what will you do is that, and if you're saying how we got this, okay, how we got this, then we know that if, okay, see, oh, if you see, then, okay, wait, I'm where I have a place. Yeah. So we have always, you know, did that. What is the, oh, sorry, wait. What is the probability of A given that it will rain or not? Sorry. It won't be like this. It will be like probability that it is raining, predicts it is raining, but it is actually raining. What it will be? Okay. What it will be? The sample space. Okay, the sample space that it is raining or not. Sorry, it won't be the sample space here, it will be sample space here actually. Okay, probability of A, because we would have, because we have the uh wait, I'm explaining it to you first. I will, let me write it. Okay, what is saying, we will find this probability like this. Okay, what is saying actually is that what is the probability that it predicts it will rain and it is actually raining. So what is our sample space? That it is raining, and what we have to predict that it is actually raining. So this is the conditional probability for this, and there will be another condition for this actually. Okay, that it is not raining, and that's how we got this. Okay, and that's how we got this actually. We are summing it all because we need to find the whole sample space that it is raining or not. Okay, it is raining or not. We need a whole sample space. Are you getting at what I'm trying to say? We need the whole sample space to predict it is actually raining or not. That they predict correct or not. Okay. So we did nothing, just the probability of weather forecast predicts rain and it is actually raining into it is raining. Okay. Weather forecast predict it will rain. It is, but it is not actually raining into it is not actually raining. We'll multiply it. Okay, and we got 0.18 plus 0.08 equal to 0.26, which is an interesting number. Okay, because we reduced our sample space and that's how we got this. Okay, now we'll do nothing but we'll just put it. Okay, we'll just put it that what is the probability of it will rain given that the weather forecast predicts it will rain. Nothing but probability of weather forecast it will rain into probability of raining. Okay, by probability of weather forecast team predicting it will rain, whether it is raining or not. Okay, they're predicting. Okay, their prediction, what is the probability of their prediction. So we'll just put all the probabilities here and we'll do the simplification. Okay, and we will get the number which is 0.18 by 0.26, and approx it is 0.962. Okay, 0.692, and this is the probability of that it will rain given that the weather forecast predict it will rain. Okay, and if it is actually approx, but if we do the more approx, then it is 0.7. So this there is a 70% chance that it will rain given that the weather forecasting predicts it will rain. Okay, so I hope that you would have no questions yet, and if you have any questions, then you could ask me in the Discord. There is a link below in the given description below, and we have a and you could ask me in the comments also. So yeah, if you have any doubt regarding this, you can just ask me. Okay, yeah. So thank you for watching it.